All right, who's ready to move on to a new unit? I am. All right, we're going to start sequences and series, and hopefully you do your homework. And judging by some of those log exams, you're going to need to do it this time. Just kidding, I haven't graded them yet. All right, so what's a sequence and series? Oh, actually, what's a sequence? We don't really care about series right now, but it's an important skill in mathematics to be able to recognize patterns in set of numbers and describe the patterns with words or equations, and to be able to continue the pattern. A sequence is just a list of numbers where there's a pattern, and a sequence can be finite, which means there's a fixed number of terms, or it can be infinite, which means it goes on forever. An arithmetic sequence has a common difference. That means that each successive term is increased or decreased by the same amount. To find the difference, you subtract each term by the previous term. So, such as if I have the sequence -1, 1, 3, 5, and 7, then I take the difference. And it's a common mistake, so remember you have to subtract the previous term from the term you're looking at. So it'd be 7 minus 5 here equals 2, 5 minus 3 equals 2, 3 minus 1 equals 2, and 1 minus -1 is positive 2 as well. The difference between each of the terms is positive 2, and it has to be the same for all of the terms, or it's not an arithmetic sequence. So if the difference is the same between each of the terms, then it's an arithmetic sequence. A geometric sequence has a common ratio. That means that each successive term increases or decreases by the same ratio instead of the same difference. So to find the ratio is you divide each term by the previous term. So in this case, I'd have 81 and I'd divide by 27. 81 divided by 27 happens to be 3. And then I would do 27 divided by 9, also 3. And 9 divided by 3 is also 3. So the ratio between each term is 3. That makes it a geometric sequence. If any one of those of your terms breaks that pattern, then it's no longer a geometric sequence. All right, so notation for arithmetic sequences. Our first term is A1. Our nth term is AN. Our common difference is just D, and the number of terms is N. Pretty simple. If we want to write a rule for the nth term, say we have the first term and maybe the 10th term, and we want the 100th term, or the nth term, any term we want, we can find it. So there are two different kinds of formulas. There's a recursive formula or rule, or an explicit rule. The difference between them, we're going to use in this class, we're going to use the explicit rule more often, but you should know about the recursive rule, and it does have its applications. In order to use the recursive rule, it's kind of limited because to find the nth term, you need the last term. So this is the nth term. This is the term before the last term, and that's plus the difference. So if I had the sequence, 1, 3, 5, if I wanted to write a rule or I wanted to find the fourth term, I would take the last term before the fourth term, the third term, in this case it's 5, and the difference is 2, and that would give me 7. So that's the recursive rule. It's very simple, very basic, but you need the last term to find the nth term. And the explicit rule, I don't need just the last term. I need other information, but not the last term. So the explicit rule formula is for the nth term is a sub n is equal to the first term plus the number of terms I have minus 1, which incidentally, if this is not the first term, say I don't have the first term and I have the third term, then this number here would need to be a 3. This number corresponds with this number. Actually, let's change the color. That's what I have all these colors for. So I'm going to put a 1 here and a 1 here. And likewise, this nth term corresponds with this number here. So I can use any n in any two terms if I need to. All right, and then that doesn't look good. What happened to my pen? Nope, still doesn't look good. Oh, I know. Okay. So it's a sub 1 plus, in parentheses, n minus 1 times d. And when you have real numbers and you are looking for a rule, you should multiply it out and simplify it. All right, so here's an example. I want to write an explicit rule for the nth term of the following sequence. I have both here. I think I want to try a recursive rule tool just for the heck of it. If you look here, each term increases by 6, so the difference is positive 6. And if you wanted to, if it wasn't that obvious, say you had decimals or fractions or something, you would have to check each term. 14 minus 8 is 6, 8 minus 2 is 6, and so on. But we can see here easily enough that that is just 6. So if I want the nth term and I write it with the explicit rule, it's the nth term is the first term, which is negative 10, plus n minus, I have the first term, so this is a 1, and my difference is 6. And I can go ahead and simplify this because I can distribute this 6 and combine my like terms. And I end up with a sub n equals negative 16 plus 6n. And that is my explicit rule. And just for the heck of it, I'm going to do a recursive rule. So I need the last term for that. Let's do, it's for the nth term, so it could be any term. But it's the nth term is equal to the term before plus 6. All right, you try. Write just an explicit rule for the following sequence, and then stop this, turn it back on when you're ready, and we'll check your answer. Okay, so if you look at this, negative 2 to negative 5 is negative 3. Negative 5 to negative 8 is also negative 3. Negative 8 to negative 11, negative 3, and so on. Your difference here is negative 3. So a sub n is equal to negative 2 plus n minus 1 times negative 3. And then simplifying that, I get negative 2 minus 3n plus 3. I got that by distributing the negative 3 to both those terms. And then I'm going to combine my like terms, and I get a sub n equals 1 minus 3n. And that's it. All right, finding the nth term. Now, let's say we have a sequence and we want to know what the 12th term is. We have 20, 14, 8, 2, and negative 4. If I look at that and calculate the difference between all of those terms is negative 6, because I'm decreasing by 6 for each term. I want the 12th term. I have the first term, so that's 20, plus this n here is 12, right? This number corresponds with this number, and this number corresponds with the term, with the number of terms that one is. Okay, so I can calculate the 12th term directly. All right, 20 plus 11 times negative 6 is negative 66. So a sub 12 is negative 44, hopefully. All right, here's one for you to try. This is tricky. So turn this off, think about it for a minute, and when you're ready, turn this on. Give it a try anyways, and when you're ready, turn this on and we'll go over it. All right, we want to find the fifth term of an arithmetic sequence. We have the 8th term and the 14th term. This is a little bit different because we don't have the first term, and we actually don't have the difference either. So I have to use what I have. So I'm going to put 14 in for my nth term, and I'm going to put 8 in for my first term. That means that I have 14 here minus, you guessed it, 8 times d. So now I can calculate, I'm going to be able to calculate my difference as soon as I put in my terms. 157 is equal to 85 plus 14 minus 8 is 6d. All right, and then when I simplify that, I get, well, I have to subtract 85 from both sides. I get 72 equals 6d. That means that d is equal to 12. Now I can go ahead and calculate the fifth term. So I have a sub 5, my fifth term, is equal to, and you could pick either one. I'm going to choose a 8, or the 8th term, because it's smaller. Anytime I can work with a smaller number, it usually makes my calculations easier. Remember, this goes here, that term number is here, and then this was the 8th term, so that goes here, and then my difference is 12. So my fifth term is equal to 85 plus, and this would, 5 minus 8 is negative 3 times 12, and that's going to be negative 36. Which means that my fifth term, which was what I was after in the beginning, I just had to go through a lot to get to the answer, ends up being 49. Okay, so let's move on to geometric sequences. First term, a1, nth term, an, common ratio, r, and number of terms is n. So the only thing that's different here is that the common ratio is r. If we want to write a rule for the nth term, we can do it also in two different ways. There's the recursive rule. Again, I need the last term to get the next term. And in order to do that, it's r times the last term. So when we wrote a recursive rule for an arithmetic sequence, we added the difference or subtracted the difference. Here we multiply by the ratio. And then this explicit rule, which means I can use any term and a little additional information, is the first term times the ratio to the n minus 1. Again, this n corresponds with the nth term, and this number corresponds with the term number that I have here. I can switch that up again if I needed to. So let's write an explicit rule for the nth term of the following sequence. So I have 1, 2, 4, 8. Remember to find the ratio. I take 8 divided by 4, I get 2. 4 divided by 2 is 2, and 2 divided by 1 is also 2. So my ratio is equal to 2. So the rule for this sequence is my first term is 1 times the ratio to the n minus 1. Pretty simple. Now you try. Stop this, and when you're ready, turn it back on. Okay, so if I take 1 and divide it by 5, I get 1/5. 0.2 is 2 out of 10, which is 1/5, divided by 1, also 1/5. And 0.04 divided by 0.2 is also 1/5. Okay, so that's my ratio. So the nth term is the first term, times the ratio to the n minus 1. Moving right along. I think we already did this. Let's get rid of it. Okay, so let's find the 7th term of the following sequence. We have to find the ratio first. So 12 divided by 3 is 4, 48 divided by 12 is 4, and 192 divided by 48 also 4. So the 7th term is equal to the 1st term times the ratio to the 7 minus 1. Oh, gross. That's so gross. Okay, I'm going to need a calculator for that. Common mistake is people are going to try to multiply this and then raise it to the 6th power. You can't do that. It's exponents and then parentheses and then multiply and divide. So it's 3 times 4 to the 6th. And 4 to the 6th is some ungodly number. Let me pull out my calculator for that. It's a big number. And then if I multiply it by 3, it's even bigger. I get 12,288, assuming I haven't made any mistakes. All right, you try. Turn this back on when you're ready. Okay, we want to find the 8th term. We have the 3rd term and we have the 5th term. We do not have the ratio, so we need to find the ratio first. In order to do that, I have to use the only information that I'm given. So I'm going to put the 5th term here. I'm going to use the 3rd term for my 1st term, and then up in the exponents, I can do 5 minus 3. Okay, so 324 is equal to 36 times r squared. If I divide both sides by 36, I end up with 9. Okay, 9. So 9 is equal to r squared. That means that r is equal to, be careful here, plus or minus 3. Remember, if I take the square root of something, then I have to account for the positive and negative values of that. Okay, so the ratio could be plus or minus 3. So go ahead and calculate. We want the 8th term. We have the 3rd term. And we have the ratio. I'm going to calculate it with the negative number first, as we have to find both solutions for both sequences. And since this is the 8th term and this is the 3rd term, that's going to be 8 minus 3. So negative 3 to the 5th, also a big number. And when I put that in my calculator, I get negative 8,748. So if I want to use the other solution now, it's just going to be times 3 to the 5th, which is positive 8,748. So this one actually has 2 solutions. That's it. So good luck. We'll see you in class next week, and don't forget to do your homework. Oh, wait, if you don't hear that, you won't remember anyway.